My name is Feng. I'm a storage architect from Alibaba Infrastructure Service Group. Today, thanks for the opportunity to be here to present Alibaba's continuous efforts to address the storage solution challenges for the hyperscale data center. My presentation today is mostly on the Dual-Mode SSD architecture for the next generation hyperscale data centers. So for today's hyperscale data centers, we are facing various changes from the storage solution perspective. Here we summarize the changes, especially for the Alibaba data centers. We have 5 high-level issues or changes we need to overcome from the storage perspective. The first one is that the workloads becomes much more diversified. Like use Alibaba as an example, we have so many business units like the e-commerce, search, cloud computing, cloud storage, as well as online promotion and so on and so forth. So all those business units requires very different workloads, and even within one business unit, because the business is going so fast, their workload is changing a lot. For Alibaba Group, we were using we were mostly buying the SSDs and storage hardwares from the vendors, but those generic storage hardwares. They usually optimize for a certain workloads. It's not really customized to a very specific workloads, which is truly using our data centers. So that's one challenge we're facing. And also because that the data center scale is becoming larger and larger. So we keep facing the pressure on the TCO, we buy so many SSDs every year. How to reduce the cost is always challenging in front of us. And also for the data centers, we cannot rely on just one vendor. We usually, for each product, we require at least 3 vendors there. So we want to keep this multiple vendors to release the strain on the supply, but also more vendors means you need to pay more costs on the qualification. So we want to keep multiple vendors, but still reduce the complexity and overhead on the qualification. So that's another challenge we are facing. And also for the standard block device, it's more like a black box, right? So I think it's a well-known concept recent days, especially for the open channel. The standard block device, from the host perspective, we cannot control the IOs inside the device. It's more like we just send the IOs to the device, and whatever the device will do, like so many background operations, GC, and so on and so forth. But for the data centers, we want to control all those data placement, especially for the latency control. Quality of service so becomes more and more important. So we want more control and more I/O determinism. The fourth issue we are facing is that the quick response to the issues, and also the quick response for the new feature request. So our experience is that when we are working with the hardware vendors, if there's an issue, it usually takes maybe 1 quarter to get that issue really fixed. We report the issue, and then talk to the field engineers, and then they talk to the internal engineering team, and then they get a log from us and look at it, and so this is your problem, this is my problem, and then if it's truly diagnosed as the hardware problem, then we ship the driver back to a vendor, and then take some time to really debug it and provide solutions. So I think it's at least 1 quarter. For an internet company, I think that's 1 quarter is too long. So we do want to have a way to address those online issues very quickly. And also for those in a very dynamic business environment for new features, we also want a very quick quick solution there to address our needs. But again, just like the bug fix, the new features also takes a long time. At the end, I think performance is truly the most important one. We want to have better and better performance, but unfortunately, I think for our current standard block devices, I think the hardware and software are kind of optimized separately. So the hardware, the software part doesn't know what's happening in the hardware side, and hardware side doesn't know what the business, the upper level storage software is trying to do. So that's kind of gaps here limits the performance improvement from the storage perspective. So because of all those challenges, our Alibaba Infrastructure Service Group, we started to address those challenges since starting from develop our own solution for the SSDs, the NAND flash-based SSDs. We started this effort since from 2016. So until today, we already released 3 generations of AliFlash SSDs. So the AliFlash V1 is a high-performance PCIe SSD. It's host-based FTL. So we have some control on the software and hardware together. It was developed in 2016 and then deployed at the end of 2016. So until today, it has been in service in Alibaba data center for more than 2 years, and we have more than 20K devices deployed in the Alibaba data centers. And so far, it's going very well, very stable. And then we moved to the AliFlash V2 into 2017, which is U.2 SSD form factor, and also we started customization for some certain specific business units, certain workloads. And compared to the purchase from the storage vendors, we successfully reduced the cost by roughly 20%. AliFlash V3 is what we are currently working on. It's Dual-Mode SSD with Open Channel supported. This is indeed my primary focus for today's presentation. For this one, we do deep optimization for the certain for the business units applications, and also this one is, as I said, it's an ongoing effort. We are in the progress of prioritize this Dual-Mode SSD. So here, let me just give a little bit more details on the productization of this AliFlash V3. First of all, this is a self-development Open Channel SSD, which is ongoing efforts in Alibaba data centers. This right-hand side, this graph here is showing the controller of this AliFlash V3. It's indeed our own controller. We work with a ASIC design company, and customize this controller, especially optimize the performance and also for the open channel usage mode. We already announced this the major milestone in the FAST 2018 this year. And also this Open Channel V3 is indeed a platform. We're not just working on one vendor, we're working on multiple vendors. So the goal there is truly to build an ecosystem, to have a unified platform and have multiple vendors to provide the hardware for this dual mode and SSD with the focus on the open channel. So this is photos for the just like sample for one of our vendors for the AliFlash V3. So this page summarizes why we choose the dual mode, especially the open channel for our next generation data center storage solutions. So the right-hand side is our high-level architecture of the dual mode. So from the bottom to the top, So the bottom part is the Alibaba Open Channel SSD. We call it AOC SSD. So it's indeed from our collaborators. We have multiple collaborators. I'll give and end of this presentation, I'll show you our partners and collaborators for those hardwares. And with the Open Channel SSD, and then Alibaba Group will build the software stack on top of it. So that's what is showing here. We have our Alibaba Open Channel SSD specification. So this is our own SSD specification. It's different from I guess you may be familiar with the Open Channel 1.2 and 2.0 specifications in the industry. Our SSD specification is it's our own SSD specifications. I think we absorb some of the good ones from those Open Channel 1.2 and 2.0, and then based on our needs and our specific requirements, we had a lot of new commands there to truly have a spec which we believe is good for the productization. And here, with this specification, we actually requires a dual mode. So which means that the hardware is exactly the same, but we can switch the SSDs in the open channel mode and the standard device mode. So the vendors can just configure the drives into either open channel mode or the standard device mode in the fab and then ship to us. The reason we choose this is because as the first generation of Open Channel SSDs, we want to keep the flexibility for the deployment. So our business units can still choose they want to do the open channel mode or they want to do the device mode. So for the infrastructure group, so we just have one unified hardware and then flexibly configure it based on the business unit's needs. With this Open Channel SSD platform, and on top of it, we have our team has our storage software stack there. We call it the Fusion Engine. It's basically a user mode storage engine, and have different capabilities like the device manager and different tools to manage do the statistics and track the IOs there. And on top of it, then we connect with different applications here. And with this architecture, we believe that first of all, we enable hardware and software co-optimization. So with the hardware and the firmware provided by vendors, but on top of it, we have our open channel drivers, fully controlled by Alibaba Group, and we have our storage engine, and we have the internal business units. So we have those three layers combined together. Then we can do a fully co-design and co-optimization. And then since we control the FTO, so we have the maximum flexibility to optimize for different workloads. We can choose for those latency application, we can choose the generic block device mode, or we can, based on the special requirement for that business unit, we can customize our FTO to their special needs. I'll have a one page to show a high-level example like what we do there. So this provides a deep integration with applications. And also, since we move the FTO from the device to the host side, so from the SSD hardware perspective, we actually reduce the scope. So with this change, we believe we can reduce the time and the complexity of the SSD qualifications when we introduce this specific hardware into our data center environment. And also, sure.
Dual mode is not the ultimate solution, it's a preferred solution, right? So
I would think so. As I said earlier, the reason we chose dual mode is kind of a trade-off, right? So I think we are the first one. I believe we are the first one in the industry to productize this open channel. So there's risks here, so we want to keep the flexibility. So the business units, they can choose. If they think, okay, I'm more comfortable with that block device, so we can switch it, draw it back to the standard device mode. So this kind of thing also sometimes depends on the expertise of the different business units. They may not have that the expertise to customize their software for the open channel. So in this way, they may choose use this block device mode, a standard device mode.
But I think if you have a dual mode, it is difficult to reduce the cost of the hardware because.
Yeah, I agree with you. That's why I think there's a trade-off at this point. So when we have the first generation massively deployed in our data center, and then we learn from it, and then we will figure out what's the best way to deploy those devices for different business units requirements. And then we can, in the stage 2 of our open channel, we will try to do like reduce the memory in the SSD to reduce the cost. That will be a stage 2 plan. But then stage 1, we are keeping the identical hardware there.
So Dual-Mode is really a staging product, like intermediate product?
I would think so, yeah.
So I have a kind of similar question. So all the FTL management moved on host side, I would imagine that because business units not down to task to do. And then I have a question. So along the way from the device to the host, is there hardware acceleration in between? Oh no.
There will be. That's in our roadmap. Yeah. So I think that's a very good question. You move FTL to the host side. First of all, there's a lot of memory consumption there, and there are a lot of CPU computation there. When we do this internally in Alibaba Group, we do see the concern from the business units regarding those, like you consume so many memories, and you consume so many CPU cycles there. It's not a fundamental blocker because nowadays in data center we have separate the computing load and the storage load. I think those storage load do have enough CPU and memory there to support the open channel. But if we can figure out a way to offload those things from the host, that would be good. It's indeed in our roadmap, like you said, those hardware acceleration. It's in our phase 2 of open channel deployment. Yeah.
Thank you.
Yeah. Okay. So this page is open channel architecture for stage 1 dual-mode SSDs. So the right-hand side is a paragraph to show the role and responsibilities between the device and the host. So compared to the traditional SSDs, traditional SSD basically encapsulates everything into the device. But here, as I said earlier, we actually move most of the FTOs to the host side. So in device, we still keep those, the NVMe commander, and then the median characteristics monitoring capability, and of course ECC engine. There's no way for the host to do the ECC, and RAID engine, XOR, and those smart. And then for the FTL functionalities, which is impacting the data placement and I/O scheduling, we move all of them to the host side, including the I/O scheduling, data placement, background data refresh, garbage collection, where leveling, as well as the band block management. So here, I think one thing I want to mention is that even though we move all those data refresh, garbage collection, where leveling to a host side, those are I think those are in the category of the media management. We actually just moved the host side should be responsible for the initialization for those handling, but the media and characteristics monitoring is still in the device. So in other words, we are looking for something like we don't really want the host side to monitoring the media and characteristics because that's too much effort, and also it's not really those kind of things is very media specific. I think it's better to give that control to the vendor. They know their NAND medium better than us. So we just want to the device to give us information to say, this media is in the risk. You need to do something to handle it. And then the host will initialize the handling. I think if you are familiar with the SSD FTO, the handling usually just you probably need to refresh the data, right? And also do some band block management there. So those will be controlled by the host, but the monitoring things will be controlled by the device still.
How does the device improve the kind of information to the host?
It's vendor specific, but a general idea there is like, the AER, right? Asynchronous event request. So that could be a measure for the device to notice the host.
So the host device interface is still largely based on NVMe?
Yeah, it's like NVMe, right? Customized NVMe, yeah.
So if the device informs this kind of AER, like video, the bandwidth, does it part the kind of determinism? It will not be.
You mean I/O determinism?
Yeah.
So I think this way is also for the good of I/O determinism. For the traditional SSD, it will do those work for you, right? Without your permission. If the traditional SSD says the data there has some retention issue, you will just move the data, and the host side have nothing to do with it and doesn't have any control there. But in this way, the device will notice the host to say, oh, you have the data retention problem. You may choose to move the data sooner or later. And then the host side, it's fully up to the host side with when to do this work. So from that perspective, you can actually achieve a certain level of I/O determinism. Yeah.
In general, do you want us to ask questions during the talk or towards the end?
Yeah, I think it's better to listen. Yeah, we have 50 minutes, so we still have enough time. Let me finish the presentation, and then we move to the Q&A part. Okay, so with this architecture, basically the host side actually gains the most important part. We have the direct access to the physical medium, maximize the utilization of the medium capability. We fully control what is really important for the upper storage software level, the data placement and scheduling, and also coordinating the garbage collection, and eventually results in the reduced write applications in critical for the SSD application. Yeah. So before I move to the give some high-level idea of how we customize our FTLs for different business requirements, I just want to give a high-level summary overview on what we do to customize in the FTLs in our data centers. So this is just a flow how we usually do that, do a co-optimization and co-design. So we started from the application tree as an infrastructure group. So we have many customers inside Alibaba group. So we talk to the different business units like Ali Cloud, Alipay, TMO, and those e-commerce. So we understand their requirements and abstract them. do the requirement analysis here. And based on that, based on the hardware we have, and also our collaborators can provide, we do co-design, co-optimization. This is a kind of a circle loop process. And then based on that, we have this generate this in-house storage solutions, and then provide these solutions back to the business unit's application side and talk to them, do you like this? And they will provide us the feedback that, oh, this truly meet our requirements, or no, I think you still maybe put more efforts on this or that. So it's kind of feedback mechanism to several runs, and then we generate the truly understand the requirements and come out optimize the solution based on their needs. So this page summarizes our software stacks for the Open Channel. The whole software stack is developed by ourselves. And then we have two versions here. One is that's kernel-mode Alibaba Open Channel SSD driver, plus a block device FTO. That's what we are developed and also deployed in our data centers. And on top of that, we have user space SSD drivers integrated with our own storage engine. We call it Fusion Engine software with the internal business units. And also on the user space mode, we also customize different FTO solutions to optimize for certain business units requirements, as well as the management and monitoring and test tools in the whole software package. So in the next couple of slides, I will just give a little bit more details on the kernel mode and user mode, and one example for that customized FTO. So for this, this is a structure for our kernel-space Alibaba Open Channel SSD Solutions. So we have this multi-vendor Open Channel SSD hardware, and of course with the firmware. And on top of that, we have our kernel mode FTL, which currently is mostly a standard block device FTL. And on top of that, as I said, we do this software and hardware co-optimization, co-design. So we always connected to our storage engine, we call it Fusion Engine, which is a user space storage engine, and then to the applications. So this works as a generic block device and cover most of the legacy use cases in Alibaba data centers right now. Our expectation that they will provide equivalent performance and functionalities as standard NVMe SSDs. It will be, as I said, it's a step one for the deployment of the Open Channel SSDs. On top of that, we do some certain customizations to improve the performance and latencies. For example, we do some I/O scheduling there and to improve the quality of service. This page shows the user space Alibaba Open Channel SSD solutions. So compared to previous page, now we no longer have the kernel mode drivers. So with the Open Channel hardware, we just connect to our Fusion Engine, which is fully in the user space. And then in this Fusion Engine layer, we have the SSD driver, which is also in the user space. And then based on the different business use requirements, we actually customize several different kind of FTLs. On top of that, we have the user space file system, and also we're also working on the KV engine for those specific applications. So with this user space, we actually achieve much lower software overhead, better performance, and also deep integration with certain applications. Still keep those optimized data placement and also the coordinated background data tasks. Regarding that customized FTO, we actually do something called object SSD, which is under development to basically instead of just providing the block API to the upper level, we have this so-called object API to upper level. I'll have one page to just show that high-level idea here. So this is our object SSD. So from the bottom part, it's still the Open Channel SSD hardware. What we show those kind of those white box here, you can think it as a NAND block in the NAND SSDs, and then we have something called object. It's basically so in the SSD you delete you erase a NAND block, right? So in this customized FTO, we actually group multiple blocks together. You can think it as a super block or band in the standard SSD concept. But now with this object API, the delete granularity will become the object. It's no longer just LBA or NAND blocks here. So this device is organized into the object, and then through the Fusion engine, then we encapsulate everything and then just expose the object API to the upper level softwares. When we say upper level here, we specifically refer to Pangu, which is our internal distributed storage system in Alibaba data centers. They have their chunk server will basically organize all the data into object and then utilize the up and down write I/O pattern to write it to our devices, to the Fusion engine and to our Open Channel SSDs. So in this way, we actually achieve much lower write amplification, significantly improve the SSD lifetime, and also improve that through the user mode IO scheduling, and we actually improve the performance uniformity and the quality of service by 5x.
Is there awareness of the objects within the drive or only in the software?
So the object is actually mapped to a physical group of the NAND blocks in the drive. But the software actually, so from this Fusion engine, we just expose the object APIs to the upper level software. So it's no longer like a LBA.
The drive is plain open channel.
Yeah, the drive is open channel.
Objects within the drive.
No objects in drive. It's software just form the object in the drive. Yeah. Yeah. So this page shows, I already mentioned the I/O scheduling and quality of service improvement several times. So here just example of what we do in the either kernel level FTO or the user mode FTO, how we do the precise I/O scheduling to improve the latency. So the left-hand side is just showing still the open channel architecture, and the right-hand side is showing a high-level idea of how we do this precise I/O scheduling in the driver-level FTO. So here we have those PU. So this is indeed Open Channel 2.0 concept. You can think it's just a NAND die. So NAND die, I think if you're familiar with that standard SSD FTO, the SSD firmware actually maintains a command queue inside the SSD. The host side doesn't have any control on it. You just send the I/O to a drive, but you don't know when the I/O will be executed. But with Open Channel, the situation is totally different. Now we have this the host has the knowledge on the priority or how critical the I/O is, and also host has the full control on the command queue for each die, each NAND component die, because the open channel. So here we just have the driver will just maintain a queue for each NAND die. We call it PU, and then the red color basically means that those kind of high priority read commands. Here we just use read command as an example, but it's the similar idea can be extended to the right. With those different priorities there, the FTO can actually reorder the commands in the queues and the driver level, and then because it's a reordering, and we can achieve the better latency, better control on the I/O for those critical one and high priority one read commands. So this just to show our experiment data from our user mode FTO with the I/O scheduling scheme, which I just described in the previous page. So you can see that for the read-only workload, we actually achieve really significant improvement. The light blue is the baseline, and the deep blue is our the user mode FTO with those I/O scheduling implemented. So it's roughly 5x improvement. And if you look at the read and write mixed workload, the improvement is even higher, especially for the average write latency. This is our current standards for the Open Channel SSD. So we already mentioned several times, we're in the stage 1. We are the first one in the industry to productize this Open Channel SSDs. We already have small volume deployment in Alibaba data centers, and the massive deployment is expected in the first half of next year. As I said, the Alibaba Open Channel is not just a single vendor or just a specific storage devices. We're targeting to build an ecosystem. It's why we work with many collaborators in our industry. So Intel is our strategic partner. We started to work with Intel since from 2017 to basically do the co-development and the co-validation. So Intel provides the hardware and hardware and the firmware, and we develop all those host-side software, and then we do co-validation. Basically means the whole software stack will be validated in Intel's standard qualification flow. Intel as a SSD vendor, I think it's very good reputation on those SSD qualification flow and also the stability. So we do expect those kind of collaboration will give us our SSD product, open channel product, a very good stability and in the Alibaba data centers. And in addition to Intel, we also work with like Unique, Micron, Hynix, Shannon, which is in Shanghai, and also Synnex Labs. Future work, as I said, this is just a step 1. We have the open channel, we open the door to give the host side the full control on the underlayer hardware and hardware devices. So we are also looking into the opportunity to combine like multi-streams, NVMe set, further I/O scheduling and quality of service optimization, low latency, high endurance solutions, QoC. I think the industry right now is moving to QoC, so we're also working on it right now. Also 3D X-point. So all those innovations into our open channel platform. Going forward, from our perspective, we believe the user mode, customization, and the hardware software co-design, co-optimization is the key methods to address the hyperscale data center faced challenges from the storage system perspective. And as a hyperscale data center, we focus on the software, but the collaboration is needed. We welcome all those hardware and solution vendors to work with us to generate the next innovations for the hyperscale data centers. So to conclude my presentation, so hyperscale data center facing unique challenges, and we believe the hardware-software integrated solution is the key, especially based on the open channel scheme. We customize all the designs by applications individually, and we are open to the industry collaborations. Right now, we are, in addition to open channel, we are also working on the near storage computing, memory computing, and new storage media. So if anyone is interested in that, please feel free to stop by, and we can discuss potential collaborations. Thanks.